Hello again. Today we're going to be working on activity A04.01, which is the SkeeterSat inventory, and you should see this activity page and find it. And this is in preparation for us to do the soldering assembly and subsequent testing of our SkeeterSat printed circuit board and actually assemble the board, and then we'll do testing. Again, this activity is designed to familiarize students with the physical appearance of a variety of electronic circuit components and to acquaint them with the precautions that must be observed to prevent static electricity from damaging sensitive components. So I won't go through all of this because we'll be working through this, but make sure you have a copy of this in front of you. Also, you will need to have a copy of the schematic. So a copy of this schematic, you can go to the webpage for this course, for this particular activity, and then you can download the schematic from that page. And you really want to be able to print it out because we're going to be using it, and then we can kind of go component by component. And this is a real helpful way for you to not only identify the components, but also familiarize yourself with the schematic, which is important for you to be able to understand how this works. All right, and another important aspect of this is that every student should have their own individual SkeeterSat kit, and we expect that every student will work on this to build your own system by yourself, your own board, as well as the subsequent testing. And so in the end, whenever you provide a report, those reports should be from individual students and not as a group to turn in. So please make sure that everybody is doing their own work. It's really important. This is important for everybody to learn electronic skills as well as how to properly test out electronics. All right, so what you should have is a SkeeterSat kit, which is should be a folder, brown folder, and it has all of the components. Again, the printed copies of the SkeeterSat circuit diagram, parts list, and circuit board layout. You will need a highlighter pen, some tape, and paper. If you have a plastic shoebox or other container to store materials and supplies as you're working on this, and if you happen to have a small hand magnifying glass, that's great. But if you don't, it's okay. You can still work on this without it. And then, of course, you should have a work table that's clean and clear. If you have an anti-static mat and grounding strap, that's great. But if you don't, that's okay. And then eventually, we're going to need all of our soldering supplies that we went over in the last video. All right, so one important part here that I want to go over is that as we're going through the parts, you're going to see that some of the integrated circuit chips or IC chips are on little pieces of foam. Those are anti-static foam, so please do not remove that component from the foam. And eventually we're going to place them in our circuit, but do not remove them from the foam until that time. All right, so I'm going to go through this together. So I'll go through. So here is the kit that you should have. And the first thing you want to pull out is this piece of paper. This is what we call the bill of materials, or the BOM. And so you want to go ahead and open that. And this is going to give us a list of all of the components that we should have in our kit. So if it happens to be the case that you do not have the SkeeterSat packing list in your brown folder, you can also download this in the same place that you downloaded the schematic in the SkeeterSat assembly module on the internet, on the course page. All right, so this is our list here. And so when I open the folder, the other thing that you probably want to pull out and make sure you have is the actual printed circuit board. So again, printed circuit board, PC board, is how you people will refer to this. This is the board that we're eventually going to solder and put together. But first we have to go through and verify that we have all of these components, or else the circuit will not work if you're missing anything. Okay, so the way that we suggest doing this is you get a blank piece of paper, and I won't tape the board down, but I'm going to keep this with our components. This piece of paper, we're going to use it for all of the small components. So like the larger component, the board, for example, the board, we're not going to actually tape down. So I'll just put this here just so we know what it looks like for you. And I'm also going to have a highlighter and a pen, and then I have the schematic, and then I also have the bill of material. Okay, so we're going to be highlighting the different components as I'm going through and taping them down and writing the designators onto our piece of paper here. So I'll start with this small envelope. And you can see here as I'm opening that this section here specifically refers to contents of small envelope. So these are all of the components that I should find in here. And there are a lot of components and they're different. And therefore you want to be really careful when you pull these out and not lose them, or else you'll have to go find another resistor of the same value. So make sure you're very careful whenever you're opening this. Okay, so the first thing I'm going to do is pick up this resistor, and I'm going to use our tool to figure out what value this is. And so here's our tool. So the first color is brown. The next color is black. So that's 10. And then this is the multiplier, and it's green. And so this is 10 times 10 to the fifth, which is 1 megohm. All right. And when I look here, I see that this relates to R12. So, and then I can also verify this with a meter just in case I'm confused about it. We should definitely do.
So hopefully that works.
And so that is 1 meg. It's 984,000, which is very close to 1 meg. Again, we talked about that 5% tolerance. All right, so then I take this and I can label it now. So I will tape it here. Probably used a little too much tape. Use less next time. And then I will label it R12. And then I have 1 megohm. The purpose why we're doing this is because right now you can see that I just have a big pile of components. And this makes it really hard whenever I want to also then go ahead and solder. And so our purpose here is that we're going to organize these components so that it makes it a lot easier for us to quickly identify each component and then be able to locate it as well on the board and schematic. So again, now I will take my highlighter. And I will highlight, I'm missing it. Okay, so great. So now I will go in and highlight R12, and there's our value. And then I'll also see that there's a quantity of 1 right here. So that's exactly how many I have. And then whenever I come over here to the schematic, I will then find R12, which is right here, and then highlight it. Okay, so now I know that I've identified that. Okay, great. So I'm going to do one more. So I'll take this one. And again, I have brown as the first one, then black, and then orange. Okay, so now we have 10 times 10 to the 3, which is 10K, which is R13. Okay, so I will take this, put it here. All right, so you're going to go through, again, there are some different, other than just resistors, you're going to see multiple capacitors. And so let's take a look at how we have 2 different types of capacitors. So they're easy to, we've got 3 different types of capacitors. So we've got some small ones, which are ceramic capacitors. And then we've got a larger one. This is an electrolytic. So pull all of these out. So this electrolytic, first off, it's polarized. So just whenever we go to solder this, we're going to see that again. But this one very clearly says 10 microfarad on the side here. So here it's C1. So I'll go ahead and put this right here. C1, 10 microfarad. Okay. And then, so whenever you look at the capacitors, you're going to see 2 different ones. One will say 104, the other says 473. And there should be 2 of the 473s and 4 of the 104s. So again, same method, you're going to take the 4 of the one type and you'll go ahead and all right. Okay, so this is the 0.1 microfarad. And this is going to be C3 through C7. So C3, C4, C5. Nope, I'm sorry, there's not a C5. There's going to only be C3, C4, C6, and C7. Okay, and so you can do the same with the other components. So a couple of other components that I just want to discuss. One of them is this component, which is a diode. And it is denoted here with D1. This is a 1 in 4001 diode. And we'll talk more about that when we get to the assembly. And the other thing is there is an LED. And the full term for LED is light emitting diode. So that's why it's also designated as another diode here. You can see D2, but that is this device. And one thing I want to mention with this is that we can see here that it says red, but you'll maybe get confused because it's a clear coating on here. But it is in fact red. Whenever the light emitted will be red, which is sometimes you'll see a external filter on some of the LEDs that might filter it out for a particular wavelength, but this particular one emits red light. So that's why you do not see the casing as red. And these are the 256 screws, if it's not obvious. Size 2 refers to the thickness of the screw, and then 56 refers to the thread type. And so 256 is a standard thread type screw size that you would use for electronics or any mechanical mounting. Moving on to the next section is the packed on black anti-static foam area. And you'll find this. So this is what we were talking about earlier with the anti-static foam. You might have a pink foam, it might be black, but this component right here, I'm not going to touch it with my hand, but this is U1, and these are Q1 and Q2. And please note, whenever we go to solder this, that Q1 and Q2 are not the same. One is a 2N3904, and then MPF 102 is the other type. The TO92 refers to the packaging that this style is in. So here are the two transistors, Q1 and Q2. Notice the markings are different in the part numbers. So you can see the one on the right has an MPF 102 part number, and then the one on the left is the 2N3904. So please make sure to look at these part numbers whenever we go to install them once we get to the assembly section. This is a speaker that is called just speaker 1. So mine was actually loose in the packaging, so yours might be loose. But that's the speaker. And then I forgot to mention, if it wasn't obvious before, that this will be this socket dip 14 pin. Again, please keep all of this on the foam pad and do not tape these parts individually to the piece of paper as you're doing the inventory. There's also going to be a card that has different components taped on. And so it's the last section called taped on an index card. Those are the different components that are there, and they should match up with what you have, with what's actually printed there. And it's important that you do not remove any of these components from this card, because it will be pretty much impossible for you to tell what that part number is. And whenever we go to do the assembly, you're going to be able to make some choices in what type of photo detector you're going to use, as well as what thermistor you're going to use. And these part numbers are going to match up to a data sheet that's important for you to use to calibrate your SkeeterSat. So please keep all of these components on, and you can just kind of tape the card directly to your piece of paper, or just leave this floating. One of the last components, it's at the top of it, it's called the battery holder. This is going to be able to mount your 9-volt battery. So maybe you've seen this before, but there's a particular orientation that will mount this, but that's what that is. It's the battery holder. These are the feet that you might have, and that's just so we'll show you how to assemble it, but you can put it on the bottom side of the printed circuit board. We're going to put those there, and then this will allow us to keep the board off of the table whenever you're operating it, to make sure that it just helps protect the board, so something metal isn't sitting underneath it that could short out a section or a trace. At the end of this, after you have labeled all of the components from the bag on the piece of paper, the inventory should look like this. You should also now have a fully highlighted SkeeterSat packing list, with the exception of a couple of things. So the first one is R2. There's some things that says TBD, that just means to be determined. It's there, that resistor is not provided to you, and whenever you see something like this on a bill of materials, that means that it's optional or might be used at a different time. For us today, we're not going to be using it for our circuit. So a couple components that you also will not have is J1, and also the header for the thermistor. And the reason that we're not going to use these is because it's unlikely that you have the proper tool, which is a proper type of crimper, in order to make this device. So instead, if you do not have that crimper, then we can just solder directly to the board. And it just makes it a lot easier and to do it properly. The other thing you should have now is a schematic that is fully highlighted with the components. And I've circled a few of the components that we don't have, which was R2 and the header. But everything else should be highlighted. All right, now we're going to move on to the SkeeterSat assembly activity.